Okay, hello guys. So we're gonna do a little review of this method for solving linear first order equations. Okay, so let's say we're gonna do linear equations. So you will have examples on how to uh, solve these linear equations. Um, so as a definition, a first order differential equation of the form a1x dy dx plus a0x y equals g of x is said to be a linear equation in the variable y. Is said to be a linear equation in the variable y. Okay, so I'm going to teach you a method to solve these equations, and then you will see the example. In the examples we use this method. Why this method works, we are going to do it the next week because we're going to learn something called variational parameters, and this method is a consequence of variational parameters. So basically variational parameters are used to solve equations that are not homogeneous. Not homogeneous means this gx equals 0. When you don't have gx equals 0, it's not non-homogeneous. Okay, so you need this method. So far we have been doing homogeneous equations. Okay, so this is our first part, and then you'll have you will have to solve problems for circuits. Okay, so when in the circuits, you see my video already, you have E of t. E of t is the voltage that is produced for a battery, for example. Okay. Okay. So where was we? So here's the algorithm. Okay. Um, so the method. The method. Okay. The method goes like this. First, let's say this is equation 1. Oh, let's say it's equation. Let's say equation linear. Okay, linear. So we need to transform. We need to transform. We need to transform the linear equation into the standard form so basically we're going to divide everything by a1 of x, and then we don't want anything in front of dy dx. Okay, we wanted of this form plus px y equals f of x. Okay, so after dividing we got f of x. Okay, so that's the first part. Second part. Okay, so in once you have it here, so you don't want anything in front of dy dx. Okay, that's the first part of the method. Second part of the method, and is what is weird, right? And that there is a proof for that. We will see the proof next week. Okay, it says we need to find the integrating factor. So what is gonna happen? Find the integrating factor, now let's call it mu of x equals e to the integral of p of x dx. And no constant need be used in evaluating the indefinite integral. Integral p of x dx. So what is going to happen is that we are going to multiply both sides times this integrating factor. So let me put it in some color because it's important. So this is my integrating factor. So why? Well, don't worry, you will see it next week. For your homework, you can just start using it for now. And then, so third step, you multiply both sides of the equation. Let's say this is, let's call it a star. Multiply both sides of equation star times ux, mu of x. That means the integrating factor, right? So how does it look? So it's gonna look e integral of p of x dx dy dx plus px y times e integral of px dx equals f of x times integral px dx. That's what you get, right? And then let's put number 4. Rewrite the equation as, so notice something really cool here. Okay, notice that this guy on the left, so stop the video. What does it look like? What does it look this to you? Okay, so stop the video for a second and think about it. So now you thought about it, so maybe you notice this is a product rule. Okay, so it turns out that this guy is the derivative with respect to x of e to the integral of p of x dx times y equals e to the integral of p of x dx f of x. So the right hand side doesn't change, but this guy is product rule. Is the derivative of the first one, well in this case the second one, the derivative of y, that is dy dx, times this one without derivative, plus y without derivative times the derivative of this guy. What is the derivative of e to the integral of px dx? Is the same e to the integral p of x dx times the derivative of this guy. The derivative of this guy is px by fundamental theorem of calculus. Okay, by fundamental theorem of calculus, the derivative of the integral of p of x is px. Okay, so now we could do more. We could do more rigorous here, right? So we could say this is let's call it another letter c, and then we have between could be 0 and x. So by the fundamental theorem of calculus, the derivative of the integral is going to be p of x. Okay, that's why you got this p of x when you do chain rule. Okay, you don't understand, so try to do it yourself by hand, and if you know cannot ask understand it, let me know, and we can discuss it in office hours. So finally, number step 5. So what is cool on step 5? You just integrate. Sorry, and sometimes I write really fast. Let me write better. Integrate both sides of the last equation and solve for what? Okay, so what does it mean? So it means, so I'm gonna do it here, but then erase it. Okay, so we integrate both sides. Oh, sorry, I mean dx, and then here integrate dx, right? So what happens when you integrate with respect to x a derivative? They cancel. Okay, so we get the following, and that's uh, basically fundamental theorem of calculus too. So we get e to the integral of p of x dx y equals integral of e to the integral of p of x dx times f of x dx. You can multiply times the e to the minus x, so now my final formula is e to the minus integral of p of x dx times e to the integral of p of x dx f of x dx. Okay, and that's our formula. Okay, so that's our final answer. That's my solution of a linear equation of this form, of the form star, this star. Okay, so that's how it's gonna look, my solution. So next week we're gonna find this formula with variation of parameters. So variation of parameters is used for not homogeneous. So we'll do variation of parameters next week, and then we're ready for our first exam. But I know you guys have presentations, so I think we're gonna have 2 partial exams and 1 final. Okay, but the first partial exam is gonna be probably on web work. Okay, so I just probably gonna choose apply problems from web work. Okay, because this is, since the title is mathematical modeling, so it's gonna be solving these real life problems uh, using differential equations. Okay, and also you can help yourself with mathematics. I'll decide how do we do that. Maybe for some problems, not for all the problems, but for some problems, probably for the half of the problems, you can use mathematics, and I'll teach you how to do it really nicely with mathematics. Okay. Okay. Thank you, guys.